distribute the things so that it is very easy to solve the questions at the time of examination. Okay, so up to helical gear we have seen. Right now, today we'll start with the bevel gear. So in case of the bevel gear, we are aware about that the bevel structure is under the criteria of intersecting shaft axis. It means that if I want to transmit motion or power from horizontal position to vertical position, then I will have to use a bevel gear. We have drawn this structure in first session of DME2 in classification bit. So in this case, you can see the bigger part is called as a bevel gear and smaller one is called as a bevel pinion. It has having frustum like cone. Frustum means what? Towards the apex, the size will reduced. So that kind of the structure we called as a frustum cone. So this kind of the structure is there, and because of this frustum like structure, the meshing is very easy for transmitting motion from horizontal to vertical or vice versa. So that is the basic role of bevel gear. So have you? Is it what? Is it also audible? आवाज येतोय का रे बाळा?
हो सर.
Okay. So this is the purpose major. Transmit the motion from horizontal to vertical or vertical to horizontal. That is the important role for bevel case. So there is no need right now to draw this diagram about bevel gear. Generally, this kind of the gears are used in differentials. So I'll show one differential video also so that you will get clear what we are going to do actually in the case of a bevel structure. Now you can see this will be the condition, and here I want to transmit the motion from horizontal to vertical. In that case, the bevel structure is arranged. The bevel pinion is situated over here. This is bevel gear. Of course, this is double bevel gear. Its main purpose is to transmit the motion from horizontal to vertical and vice versa. So you can see here, while transmitting the things, what will happen? Suppose if I give the rotations or motion to bevel pinion, in that case, I will have to transmit C like this. Horizontal. The vertical motion can be easily transmitted from vertical to horizontal end. So this is the main purpose of the bevel gear. So how it can be used in differential, that also we'll see. See here, this will be the structure. In case of a differential, yes, in this centripetal force and all that. See, this will be the main purpose. The horizontal motion converted into vertical motion and vice versa. So this is the major role because of which we are using bevel gear. So this is spiral bevel pinion and gear. It is having spiral structure. As we have seen the helical structure, it is having helix angle 23 degree. So likewise here also helix angle is there. So that we called as a bevel angle, and through which meshing will done and the motion will transmit. Bevel gear cannot be replaced by any other gear. Why? Because as we know, it is having perpendicular transmission of the motion. We cannot use spur gear. We cannot use helical gear, rack and pinion. We cannot use internal gears. Only bevel gear is serve the purpose of transmission of the motion from one horizontal plane to vertical plane. Worm gear also we cannot use. So that's why bevel gear design is important for our case while transmitting motion and power. So this kind of the scenario is there. Again, we are going to design this kind of the bevel gear according to spur gear. So by taking the base of spur gear through which we are going to design. In helical gear also we have seen the virtual number of teeth. So same nature we'll have to find here, and we'll have to consider the things for transmitting motion so that design will be easy. Correct? In case of the bevel gear, if I design on the basis of angle and all that, bevel frustum cone, custom size and shape. So there might be chances of difficulty for that case. So that's why we are going to design by taking the base of per gear. So this will be the important part while designing the things. The basic structure is like this here. So no need to draw. Of course, the rotations are while you can see the rotations while moving from bevel pinion to bevel gear. The rotations are important. You can see the bevel pinion is moving in anti-clockwise direction and bevel gear is moving in clockwise direction. So according to that rotation, meshing will be occur. Of course, this portion is called as a here will have to fit the shaft through which gear is rotating. And here also the bevel pinion shaft, both are meeting with 90 degree, that is intersecting shaft axis. So that's why we called as an intersecting shaft axis criteria gear for bevel case. Is that understood?
Yes, sir.
Okay. Rest members, बाकीच्यांना
Yes, sir.
कळालं का ते?
Yes.
Okay. So this is about the structure. Now few points we'll have to write for understanding the things. Write down. First point, while transmitting, first point, while transmitting motion as well as power, motion as well as power, the arrangement of shaft, arrangement of the shaft is intersecting, arrangement of the shaft is intersecting. Correct? So of course it is called as an intersecting shaft. Second point, it is having frustum, frustrum, frustum like cone, frustum like cone mean size of the gear pair, it means pinion as well as gear. Size of the gear pair decreases towards apex outside, towards apex. Third one, right down. There are various types of the bevel gears which can be used in industries. You can write types: straight bevel gear, spiral bevel gear, helical bevel gear. Helical means it has having helix angle. Spiral upon the body. You know, straight bevel gear, it has having straight teeth as like a square gear. Okay, so this will be the third point. And of course, no need to write the shaft angle is 90 degree. Then next point, advantage. Basic advantage you will see for bevel gear. Advantage. First, it transmit motion. It transmit motion between two intersecting shafts. TW. Two intersecting shafts. Intersecting shafts. This is the only gear. That's why this is one kind of the advantage. Second, right on. Bevel gears are available in various sizes. So you can see for differential, the size is different as per the load, and whichever is the fan arrangement we have seen in the video, its size again depends on load condition and load condition on the basis of load condition. So various sizes in which we can manufacture it. Third point, right down. While running in high speed, while running in high speed, create less noise. Less noise means less vibration. It means proper machine will occur. Less noise. Next one, efficiency of bevel gear is high. I will take it up to 95%. Right down. Efficiency of bevel gear is high. It means up to 90%. In the rather 90 to 95 actually. So these are the basic advantages. Next will be the limitation. Write down limitations. Difficult to manufacture. Why? Because the proper tooling, special tooling are required to maintain that custom angle and through which it will be designed. It is not like spur gear. Straight tip direct manufacture केलं single point cutting tool आणि तयार झालं असं नाही. So it has maintain the custom like structure and so on. And for that tooling is required. Therefore, it is difficult to manufacture. Of course, if difficult to manufacture, it is having more cost. It requires more cost. So these are the basic disadvantage of bevel gear. In case of application, you can write down in automobile differential gearboxes. We have to use bevel gear arrangement. Okay, so these are the basic things, and we are going to study the bevel gear. Now, see here. In gearboxes, there we can use a double spur gear very easily. We can use a double helical gear while transmitting motion, but we cannot use helical plus bevel gear or spur plus bevel gear in case of gearboxes. I'm talking here because both the axes are different, and for that axis, if I want to match the things, it is not possible from bevel side. Because the role of bevel side, you can see the spur helical gears are having circular cross section, and it can be transmit motion from easily in a one plane. But here the two planes are required, horizontal vertical or vertical to horizontal. That's why it cannot be matched. So त्यामुळे बिवेल गिअर हा फक्त आणि फक्त सिंगल यूज असतो गिअर पेअर. त्याच्या व्यतिरिक्त त्याला दुसरा कुठला गिअर बॉक्सेस मध्ये आपल्याला अटॅच करणं rather difficult आहे. Impossible म्हणता येणार नाही, difficult आहे. So that's why bevel gear, it has having own advantages, and according to that it serve the purpose. कारण दुसरा कुठलाच रिप्लेसमेंटला गिअर वापरू शकत नाही आपण. स्पर गिअरला रिप्लेसमेंट हेलिकल करू शकतो, हेलिकलला इंटरनल गिअर करू शकतो किंवा रॅक एंड पिनियन करू शकतो, बट इट इज नॉट पॉसिबल इन द केस ऑफ बिवेल. Okay, so these are the basic application. The question will be like this in this manner, whatever slides we have studied. The bevel structure, what kind of the structure, frustum like structure, and what are the types of the bevel, and what is the major role, what kind of the intersecting or shaft axis arrangement for bevel gear. So these kind of the question will be asked in the exam. Next, bevel gear terminology. Now, while studying the terminology, basically we are going to learn the parameters. As like in case of the spur gear, we have seen spur gear in single plane, and second thing, it doesn't have any angle. Correct. In case of helical gear terminology, we have seen helix angle alpha because teeth are cut in angle. So that is comes under helix angle for helical gear. Now in this bevel gear, you can see the first diagram. Here the structure is having some angle. So at the time of meshing with intersecting shaft axis, it has to maintain some angle in between gear and pinion. So that angle is called as a pitch cone angle. Remember, pitch cone angle. So I'll show here. See, firstly, you can see this will be called as a gear, bigger part. This is pinion, smaller one. Correct. आता हा पिनियन आहे, दॅट्स वाय याचा डायमीटर असेल डीपी, डायमीटर ऑफ पिनियन. हा गियर आहे, याचा डायमीटर असेल डीजी, सेम नोटेशन. So and the two gears and pinions are mesh in a perpendicular direction or perpendicular way. So that's why intersecting is angle is theta. Of course, theta किती असेल? Tell me, theta 120 degree, 30 degree, 60 degree, 90 degree. Which angle? Tell me.
90 degree.
Of course, it is 90 degree because of intersecting shaft axis. Correct? So theta is 90 degree. So this gamma P is called as a pitch cone angle for pinion. Correct? Pitch cone angle for pinion towards the end. See, this will be the end of pinion. This will be the end portion of pinion. It has having frustum like structure. Frustum म्हणजे काय? Towards the apex. म्हणजे वर जाईल तसं त्याची size कमी होत जाते. So this angle, if I can take, that we called as with respect to pinion, pitch cone angle for pinion. आता आपण याला notation दिलेले gamma p, alpha helix झाला, phi pressure angle झाला, theta intersecting चा झाला, आणि for our understanding, we'll have to maintain gamma p, pitch cone angle for bevel pinion. ठीक आहे, कन्फ्युजन होणार नाही. बऱ्याच बुक मध्ये याला थीटा पण घेतलेला आहे, थीटा पी आणि थीटा जी. सो इन्स्टेड ऑफ दॅट आपण स्टँडर्ड पद्धतीने जाऊ, जे काही स्टँडर्ड बुक्स मध्ये लिहिले. गॅमा पी दॅट इज pitch cone angle for pinion, gamma g pitch cone angle for gear. हे झालं पहिलं. दुसरं, second thing, so while maintaining the things, you can see the back cone angle is also important. गिअरचा बॅक साइडचा अँगल म्हणजे हे बघा, हा गिअर बॅक कोन अँगल, and it is having beta notation in the beta दिलेलं. So beta indicate back cone angle. Generally this also important because toward the frustum apex side it will reduce the size. तर तसंच बॅक साइडला पण अँगल हे रिड्यूस होणारच. So that angle will have to consider beta, and this will not be 90 degree. हा 90 degree कधीच असू शकत. So this will be the things. Then the major parameter you can see here, RBP, mean radius of pinion, bevel pinion. ठीक है, this is RBG, mean radius of bevel gear. So that radius will have to consider from center to one end. So that will be the radius we have to consider. आणि सगळ्यात महत्वाचा असेल हा pitch cone distance, OC. You can see center OC किंवा is equal to OA. OA. This we called as a pitch cone distance. So while comparing with bevel pinion and gear, I will have to calculate this AO value. जर मला AO value calculate करायचे असेल तर मला I will have to consider pinion as well as gear structure. Correct? So this is the basic regarding the terminology of bevel gear, pitch cone angle, intersecting shaft axis, intersecting angle, back cone angle, pitch cone distance, radius for pinion as well as gear, and the diameter of pinion as well as gear we have seen. Is that understood?
Yes, sir.
ठीक है, ड्रॉ करा हे व्यवस्थित ड्रॉ करा. So then we'll move for the terminology and their formulation. Just draw it carefully. Of course, small b face width. Face width कधी बदलत नाही. त्याचं नोटेशन आपण बीच ठेवतोय एव्हरीवेअर. Bevel gear terminology, you can write and draw the things. this carefully, and after completion, let me know. झालं का रे पवन? बोलिस, झालं का रे? शिवांश, अविनाश, स्नेहल, झालं का तुमचं?
एक मिनिट सर.
लेक्चर चालू आहे. ओव्हर. योगिता.
Yes, sir.
बाकीचे झाले का रे ड्रॉइंग? Write down one by one. Gamma P and gamma G are notations. Right here from your side. Gamma P and gamma G are pitch cone angle for pinion as well as gear. Pitch cone angle for pinion as well as gear. Correct. Next, theta, intersecting angle. Theta, intersecting angle. Then beta, back cone angle. Back cone angle. Beta. After that, dP and dG are diameter of pinion and gear. Diameter of pinion and gear. dP and dG. Diameter of pinion and gear. Right? Now RBP, radius of bevel pinion. RBP, radius of bevel pinion. This is क्या? RBG, radius of bevel gear. Radius of bevel gear. Then capital CO is equal to capital CO is equal to capital AO. Capital AO, which is equal to, write down, pitch cone distance. Pitch cone distance. Okay. लिहिलं का रे सगळं? Have you written this? Notations लिहिले का सगळ्यांनी? बाळांनो.
Yes, sir.
So this is about the case. Now from the diagram, we'll write the equations. Now see here, as the shaft is having intersecting shaft axis. So can anybody tell me the equation regarding pitch cone angle for pinion and pitch cone angle for gear? Anyone? This is gamma P, suppose, gamma G and theta. Can anybody tell me the equation for this? Vikram, Sumit, Ashutosh.
Theta is equals to gamma P plus gamma G.
Gamma P plus gamma G. Anyone? Any another equation? So see here, this is intersecting shaft axis. So intersecting means it is having theta, and theta is having angle, of course, intersecting 90 degree. Now, while making the 90 degree, we know by adding each cone angle for pinion and gear, that will be the value of theta, 90 degree. So write down this equation. Gamma P plus gamma G is equal to 90 degrees. While calculating, suppose gamma P is given, so I can calculate gamma G is equal to 90 minus gamma P, like this. So this is the first terminology or equation in terms of pitch cone angle. Now, can anybody tell me the equation for, suppose we are taking for pinion, tan of gamma P. Tell me what will be the equation? Diagram of pinion. Just you can check and tell me tan of gamma P. Pitch cone angle for pinion. Tell me.
dp by 2 upon r dg by 2.
Correct. Pinion by 2 because half of it divided by here and it's half dg by 2. So as we know, diameter by 2 is nothing but radius rp, radius of pinion, radius of gear. Correct. But we have not seen this term rp rg. We have seen rpp and rpg. So I will have to convert these things into number of teeth. So always remember while considering Zp by Zg, number of teeth on pinion divided by number of teeth on gear in case of tan of gamma p. Very important, tan of gamma p. Just write down this and tell me the equation for tan of gamma g directly. What will be the equation of tan of gamma g? Tell me, Yogita. Astor. Chitra.
Inverse of tan gamma p, sir.
Of course. Or you can write like this also. Simplest way. See, dg by 2 divided by dp by 2. Where there is a pinion is always on numerator side. Where there is a gear is always on numerator side. So I can write rb by rp, which is equal to zg by zg. That's it. So this will be the condition in case of calculating the angle of pitch cone gamma p. And through which we'll get the gamma p. Gamma p मी इथं put up करणार मला gamma g मिळेल. So या पद्धतीने कुठलं किंवा vice versa. So these are the major things. I think you have noted this. Then can anybody tell me how I can find the equation of pitch cone distance? Pitch cone distance, जो कि अपन लिहून घेतलेला होगा. So we have written that is PO is equal to KO. त्याचं दोन फॉर्म्युलेशन सांगू शकतो का डायग्राम मध्ये? It's called as a pitch cone distance.
So square root of rp square plus rg square.
Correct. So it is just like a Pythagoras. You can see the diagram baga. So I will have to write as like a resultant summation of horizontal forces and vertical forces. So diameter of gear, correct, but it with respect to half, that is dg by 2 bracket square plus dp by 2. So likewise we'll have to calculate pitch cone distance. Pitch cone distance. So write down these things clearly. Notations, you are aware about the notations. ओके, याच्यावर एमसीक्यूज असेल तुमची एक्झाम, तर याच्यावर काय विचारतील माहिती का, एक अननोन असेल, बाकी सगळं दिलं असेल आणि पिच कोन डिस्टन्स काढा म्हणतो, तर त्या केसमध्ये तुम्हाला हे माहीत असणं गरजेचं आहे. किंवा पिनियन पिच कोन अँगल कॅल्क्युलेट करा किंवा गिअर, त्या केसमध्ये दोन व्हॅल्यू दिल्या जातील आणि त्याच्या थ्रू तुम्हाला कॅल्क्युलेट करायला लागेल. म्हणजे सिम्पलेस्ट फॉर्म्युला यू कॅन यूज. So this is the things about the terminology. One of the major terminology also I will tell you here. Actually ते विचारलं नाही आजपर्यंत, मी तुम्हाला रफली सांगून देतो की नाही कसं बीईच्या प्रोजेक्टला तुम्हाला ते लागू शकतो. Clear. So while calculating the radius, which we called as a bevel pinion radius, this is zoom करून बघा, RMG इथे लिहिलेलं आहे. ऑफकोर्स हा बिवेल गिअर आहे, हा बिवेल पिनियन आहे. तो RMG म्हणजे काय, मीन रेडियस ऑफ गिअर. मीन का म्हणले, बिकॉज इट हॅज हॅव्हिंग चेंजेस इन द साइज अँड दॅट साइज त्याचा हाफ आपण घेतो, दॅट्स वाय मीन. करेक्ट. मीन रेडियस ऑफ गिअर तिथं बघा तसंच आहे. मीन रेडियस ऑफ पिनियन कुठलं तरी एक समजून घेऊ आणि त्याच्या पद्धतीने आपण पुढे जाऊ. ठीक आहे. सो विल लर्न अबाउट पिनियन, कारण गिअरचं पण सेम होतं. सी गिअर RMP मीन रेडियस ऑफ पिनियन, त्याचं काय आहे, DP/2 म्हणजे डायमीटर बाय 2, डायमीटर ऑफ पिनियन बाय 2, बिकॉज ओव्हरऑल डायमीटर इज एंड टू एंड डिस्टन्स फॉर पिनियन केस आय एम टॉकिंग. Correct. So DP/2 RMP, and it is somewhere matching with respect to face width, which is at the center of that face width. If I take the angle, this having angle gamma p for pinion, same angle here it will translate gamma p. So if I take this value, and you can see this will be the difference. The difference is, we can say it is B/2 sine of gamma b. How it came? See, sine of gamma p is equal to, कोण सांगेल मला, sine of gamma p is what? This sine of gamma p, that is mean radius of pinion divided by B/2. That's why this distance is B/2 sine of gamma p. Likewise, आणि इथे पण तसंच आहे. फक्त गॅमा पी च्या ऐवजी पिनियनच्या जागी गिअर येईल, गॅमा जी आहे. ठीक आहे. तो याच्या रिलेटेड मी सांगेन, आजपर्यंत विचारलं नाहीये, बट आपण घेऊ. सो जस्ट राईट नेक्स्ट हेडिंग, मीन रेडियस. मीन रेडियस, मीन रेडियस. ड्रॉ दिस टू डायग्राम, पिनियन आणि गिअर. त्याचे नोटेशन्स ऑल्सो. मीन रेडियस ते पण फॉर्म्युला बेस विचारू शकतात एमसीक्यूज. माहित असेल मी घेतो मीन रेडियस. आणि ऍज अ होमवर्क तुम्ही लक्षात घ्या, हेलिकल आणि स्क्वेअर गिअरचे फॉर्म्युलेशनचं डिस्ट्रीब्युशन करा. तुम्ही दोन एंडला एका पेजवर लेफ्ट साईडला स्क्वेअर गिअर, हेलिकल गिअर एक एक फॉर्म्युला लिहित जायचं, तर तो तुम्हाला हेल्प करेल एक्झामिनेशन मध्ये. म्हणजे ते कॉस्ट स्क्वेअर आहे का कॉस्ट क्यूब आहे, या सगळ्या गोष्टी ऐन वेळी सोडवताना काही समजत नाहीये. सो बेटर यू प्रॅक्टिस फ्रॉम युअर एंड. त्याच्यात एकच नवीन टर्म आले, मीन रेडियस, RMG आणि RMP. मीन रेडियस ऑफ बिवेल पिनियन आणि तसंच बिवेल गिअर. Draw it carefully. एक डायग्राम जरी काढले तरी आपल्याला समजू शकतो. आहे का रे डायग्राम? उत्कर्ष, is it over?
Yes, sir.
Now see, I'll write the equation. You are having diagram. So just write down RMP, mean radius for pinion. RMP, I'll write here, mean radius of pinion. Mean radius of pinion. Correct. And same RMG, mean radius of gear. Correct. So while writing mean radius of pinion, can anybody tell me the equation? RMP is equal to what from the diagram? Pinion support बोलते. RMP is equal to what from the diagram? Tell me.
RP minus B by 2 sin gamma P.
Correct. एकदम बरोबर. So instead of RP आपण असं लिहू समजण्यासाठी, that is TP by 2 हाफ आहे त्याचा minus diagonal distance B by 2 sin gamma pinion. तसंच RMG EG by 2 minus B by 2 sin gear. म्हणजे this will, as I told you, how this B by 2 is, it is from, you can see, from the diagram, I'll get Rn space width by 2, and this is for R and Pinion. Which will calculate B by 2 sin gamma. Okay, so this will be the major things. There might be chances to ask. Of course, module gear ratio, it cannot be changed. त्या गोष्टी काही बदलत नाहीत, लक्षात घ्या. Gear ratio तोच राहतो, modules पण D by Z च राहतो. Okay, so I'll just write here module. Module is D by Z, diameter of pinion as well as gear. I can write here module is equal to, in case of bevel, TP by ZP. In case of gear, TG by ZG. This is about the module. Now gear ratio, of course, gear ratio in 3 ways. That is number of teeth on gear divided by number of teeth on pinion, which is equal to diameter of gear, diameter of pinion, and RPM of pinion, of course, maximum असणार ते, आणि RPM of gear. ठीक आहे, which is equal to, आता याच्यात जर तुम्ही बघितलं तिथे कन्फ्युज व्हायच नाही. आपण मगाशी एक इक्वेशन तयार केलं बघा. काय होतं ते इक्वेशन? tan of gamma g, आपण म्हणलो की zg by zp. बरोबर. गिअरचे सगळे न्यूमरेटरला डिनोमिनेटरला पिनियन. आता इथं बघा तुम्ही गिअरच आहे, टॉप साइड टॉप साइड. सो या दोन्ही इक्वेशन साठी किंवा मी हे दोन्ही इक्वेट करू शकतो कोणाशी? tan of gamma g. हे लक्षात ठेवायचं, हे फार महत्वाचं आहे. किंवा डायरेक्ट इक्वेशन सोप्या भाषेत जर मी लिहून घेऊ शकत असेल तर असंही लिहू शकता तुम्ही. हे बघा, tan of gamma g is equal to zg by ZP which is equal to diameter of gear by D. याच्यातली कुठलीही एक टर्म अननोन असेल ती आपल्याला कॅल्क्युलेट करायला या इक्वेशन थ्रू येईल. ठीक आहे. So this kind of the things are there for calculation. Okay. हे समजलं का रे बाळांनो? Is that understood?
Yes, sir.
So, एक लक्षात घ्या एमसीक्यू बेसला तुम्ही असा विचार करू नका की न्यूमरिकल विचारत नाहीत बरं का. असं काही नाहीये. ऍक्च्युली जे काय आतापर्यंत झालं डीएमई 1 आणि याला ठीक आहे म्हणजे ते नवीन होते सिस्टीम एसपीपीयू ची पण आता ते काही तेवढा एक्सक्यूज देणार नाहीत. आपण ओव्हरऑल आपल्याला सगळी माहिती असायला पाहिजे. ठीक आहे. याचा स्क्रीनशॉट काढून घ्या आणि नेक्स्ट लेक्चरला नेक्स्ट कधी आपल्याला उद्या 9ला चालू होईल लेक्चर. ठीक आहे. सो उद्या हे सोडवून या. 2 स्टेप किंवा मॅक्सिमम किती 4 कॅल्क्युलेशन आहेत. 4 स्टेप मध्ये हे तुम्ही कॅल्क्युलेट करू शकता आणि जे काय आपण मागे बघितलं त्या पद्धतीनं आहे आणि अशा टाइपचे एमसीक्यूज ला तुम्हाला विचारते. सो राईट डाऊन अ पेअर ऑफ स्ट्रेट बिवेल गिअर. A pair of straight bevel gear consists of 28 teeth on pinion, 28 teeth on pinion and 42 teeth on gear. If the shaft angle is actually हे द्यायची गरजच नाही. shaft angle bevel मध्ये 90 degrees असला पाहिजे. So shaft angle is 90 degree. Determine first PCD, pitch circle diameter of pinion and gear म्हणजे DP आणि DG. Second, pitch cone distance AO, capital AO. Third, pitch cone angles gamma P, gamma G. And fourth, mean radius for pinion as well as gear. Mean radius of pinion as well as gear when module 5 face width 40. Everything is given. फक्त फॉर्म्युला मध्ये इक्वेशन टाकत जायचंय. You will get the answer. ठीक. चल. So we'll stop here. We'll meet tomorrow 9 AM.